Okay, I'll repeat this. Now, as I said, box plot usually used in your descriptive statistics, and it is a method for your, representing it graphically, the groups of numerical data. Okay, now as you saw in this example, we had this numerical data, two values. Okay, and they are represented through quantiles or quartiles. You can say QUARTILES, quartiles. Okay, now box plots may also have, you can have, say, the lines which are extending from the boxes, like you can see here. Now, these are known as your whiskers. Okay, these are known as your whiskers, and it indicates the variability outside the upper and the lower, you can say, quartile. So if this is my upper quartile, it shows the extent, you can see it is indicating that the value, some of the values, how much values you can say are extending beyond the upper, and this lower, you can say this is the lower whisker. Okay, so variability outside the upper box or the upper quartile, you can say, and the lower quartile is displayed through the whisker. Okay, and that's the reason, in some cases you also call this box as your box and whisker plot. So if you look in some of the statistical books and so on, you'll get this type of a plot. We also get outliers. Now, outliers are not displayed here. Oh, it is displayed, yes. Now you can see this circle here. Now this is an outlier. Okay, what is an outlier? Outlier usually is plotted in box plot with a circle or a point, you can say. It can be either filled or not filled. Now, outliers are extreme values. Outliers are nothing but extreme values. It can be extremely very high, or it can be less. Okay, either very small value or very big value is usually represented as an outlier. Okay, so that also helps us understand how my data is distributed. Okay, how my data is distributed. Now you can also check the different indications of your box plot. We can also have a line drawn in between. Okay, now I'll make some changes to this particular plot, and then we'll come back to this. Now it also indicates the skewness of the data. Okay, now all these are some statistical things, but we are not going to go there right now. Let us make some changes to this plot and see how we can display it in a different form altogether. So what I'll do is I'll display with a notch here. Okay, so I'll make a change here. I already have the input data. Let us make some changes in my function. So we have given the data, we have given the X lab, we have given Y, and we require the main has been given as mileage data. Okay, now let us give some more parameters. We have a parameter called notch, N-O-T-C-H. Okay, notch equal to, let us give true. Okay, and we also have press enter. I'll press enter here. Now, based on the width, I'll also set the variable var width. Okay, equal to true. You'll see the change which is going to happen in your. And we also want some new colors here. So I'll give colors as well. So I want each, you can say, box with a different color. Okay, so let us give some randomly. I can give some, say, green. The basic colors will give green, yellow, and I'll give one more. Let us give, this time we'll give purple. Okay, so 3 colors. Let's put here the comma. Okay, now we'll indicate the high names also. So for each of this one, instead of this, 4, 6, 8 there. Okay, I'll name it as, so give names. We can give this as a C into bracket. The first one, high. Second one, medium. And if you want, you can give anyone which you feel like. I'll just show you how to give it. Let us give low. Okay, so if I run this again, 1, 2, this final. Now here it is. Okay. Now based on this, you can see, because I have kept notch equal to true, and I have given the where width equal to true. Okay. Based on the width and the colors we have already specified, you can see there is a notch created here. Okay, so we get this a different shape for your, the box plot as well. Okay. Now, if you want to know more about the box plot, because box plots are something very interesting, and how we can look into it, we can, what you can do is you can just let us go to the website. Okay, and we'll go Google. Okay, box plots in stats. Okay, in statistics. Right, that is different. You can see here, it gives you the full explanation of your box plot. Okay, so you can go through this and try to understand this much better. Let us go to this one, towards data science, the first one. Okay, now find one. Let me. Okay, now in this they have not presented this in a. They have just put it downwards. So here you can see, now this is your whisker here. This is the whisker. This is the other one. Okay, if you can consider this to be the upper one, this is your 25% quartile, and this is your 75%. Okay, usually you'll find the data, the line in between is your median, which we saw, and the round circles, these are your outliers. You can see this one. Okay, and how it is calculated, they have also given the formulas. Okay, if you want to explore into this more, you can just go through multiple definitions which are given for your box plots. Okay, so like this, if you want, you can also go ahead and try to understand. Fine. So we have this whole tutorial given here and the data. Clear? In fact, I would want you all to go through this, because it is a very, you can say, a very important type of a box plot, especially when we want to understand the data. Okay, now this would be a part of your advanced R. When we come in the next semester, we have advanced R. So that in that syllabus, excuse me, we will be trying to understand what it represents and how it has to be interpreted. Okay. So for today, I think this much is enough. The next type of plots, we have a histogram, which I would like to show. I think we have 10 minutes in hand. We can complete this histogram. So let us create another file. Okay, now histogram usually represents the frequencies of the value. Okay, some of you might say, it looks similar to your this one bar chart, but it is not. Your histogram usually represents the frequency of the values of the variable. Okay, so for this, again, I'll require some values. So we'll create a vector first. I'll quickly do it and show it to you. Let us give CV equal to, create some values here, say 9, 13, say 21, 8, say 36, 22, 12, so 41, 33, 19, say 50, not 56, it's to pick 33, okay, how many we have done? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. Stick to some 10 values or 11 values. 10, 11 is more than, okay, let's do this. Okay, some numbers you can see 13, 31, 19, 36. Okay, fine. Now for this, I'll just give the function we have to use as hist. Okay, hist into round bracket. The values is the value which we have to give. I'll give the x label equal to, let us say these are some weights or something like that. Say weight, and I'll give the color COL equal to, let's say, give yellow. Fine, and I'll give the border as well. Border for the bar. Okay, let's give say blue color. Okay. Now in this, what happens is it. If you look at the bar chart and the frequency, you'll feel that it looks the same, but it's not. So let us run this first one. Okay, now this is looking, this is my histogram. Okay, because I have not given any name to the title, and now you directly get this histogram of V. Fine. Let us give some, make some changes here. Okay, we have already given the color. We'll give the limits as well, because you can see this is going beyond the whole thing. So I'll make some changes here. What I'll do is I'll give, say, X limit. Let me specify from, let us say from 0 to 40 is more than enough. So I'll give C into bracket 0, 40. Okay, that's my X limit. I can also set the Y limit. So I'll give Y limit equal to, now this is 0, 0, 1, 2, 2. Let me keep it up to say 4 or 5 something. So I'll give from 0, say 5. Okay, and we can give some say breaks. Let's give comma break. Breaks, not break, breaks. No, breaks is used to maintain the width of each bar. Okay, if I want to maintain the width of the bar, I have to give breaks. So let us give a value here. So 4 is enough, I think. Let us run this and check whether, okay, now this is looking more horrible. We'll keep a simple one. Let's have this. Okay, I've made it 5. Right? No, this is not that good. We'll come back. When we come back, we'll explore more into this histogram. Okay, with some titles and so on. Fine, I'll give another example. Now, just quickly, I just showed you how to use the function. Okay, we had a vector with some values here, and we created the histogram by using the function hist. Okay, the first parameter it takes is the vector values, the vector containing the numerical values used for the histogram. If I want, I can use main and give the title for the chart as well. Call is for the colors. If you want, I have given yellow here. We can also specify the border. So for border, we have given the blue color, the x-axis or the x label, you can see the description which I want on the x-axis. Then I have specified 2 additional, you can say, parameter here is your x limit. Okay, we have specified the range of the values on the x-axis, and we have also specified the range of the values on the y-axis. You can see this now. Previously, I was getting this decimal points or something like that. Now we have from 0 to 5, and here we have given 0 to 40. Okay, now if you want, you can make some changes in your values and we can get a better chart. Okay, secondly, there's another variable which we had given, that is your breaks, which is used to mention the width of each bar. Okay, so we have given 4, 5. You can just use some try and error and give some different values, give some higher value and check how it looks like. Okay, when we come next, we will look into histogram more. Okay, and try to take some other example, might be from some data file or something. Instead of taking it from this vector, the values, we'll use some other values and try to give it. Okay, so if you want, let us reduce this values and make this a bit better. So let me repeat some values here. So here we have 22, 22, 8 is there. Here let me give 9. This 8, 9 is there. I'll change this also to 9. Okay, let me check whether there's any change here. Okay, this is a bit different now. So you can see this number between this. Okay, 9 is coming how many? 3 times. So 9, 1, 2, and 3. Right? So like this, if you want, let us reduce this also, make it as 31. Okay. Fine. So I've reduced it. I've repeated the numbers so that I get a better view. Okay, now you can see this. This looks better. Okay. We will take some more examples because here, as I said, histogram is going to show the frequency of the values. So that's the reason I repeated some numbers so that I get the frequency of that particular number and I get a better view of this histogram. Clear? We don't have any number in between here somewhere. Okay, and because of the range which we have given, it is giving me this. So 9 is coming here somewhere. Okay, and you can see this box getting plotted. Okay, so this is this center might be 15 something. Fine. We'll take a better example when we come next. Okay, so that's all. You can just punch in your attendance. Okay, you punch in your attendance in the chat. The advanced graphical ggplot, which is some advanced graphical, some packages are available. We are going to do that as well. That is a part of some advanced features in graphs. So when we come, we have some line charts. I have to cover some basic charts and then we'll start using this line chart and scatter plot. That is 2 things which you have to do. And then when we come back, we'll start using this data set. We'll look into the functions like mean, median, and mode, and how to represent that in the graphical format as well. Okay, and we'll also see how to handle the null values. So we have to still see many things which are left. Okay, so when we come next, we'll try to cover this basic charts as soon as possible, and then move on to your data reshaping and data restructuring, exploring your data more. Okay, handling how to handle your null values and so on, how to do linear regression. That's one thing which I would like to show you, even though it is not a part of this syllabus, might be in the advanced R programming. You do have all this regressions and all, but I would like to just show you one small demo of linear regression, because that is the basic, you can say, regression, which is, you'll find it everywhere. Okay, so when we look into the data set, how to handle reshape the data, how to handle the null values, and how to plot the graph. Okay, all this is a part of your EDA. Okay, exploratory data analysis. Okay, that, and we'll come to that topic again, because that is again after we complete the graphs, I'll explain you about EDA in depth. Okay, so that's all for today. When we come next, we'll look into the more basic graphs. I will start with histogram only, and we'll go take from there further. Okay.